So yeah, hi everyone. I'm Martha Hart. I'm an associate for Arup based in Sheffield, and I'm going to talk to you about the Leeds District Heating Network, and tell a bit of a story about how waste and the data associated with the district heating network can help decarbonise our heating going into the future. So in Leeds, the Leeds incinerator is known as the RURF, the Recycling and Energy Recovery Facility. That scheme is also operated by Veolia. They collect and process around 165 tonnes of black bin waste. So this centre includes a recycling separation stage before the incineration. So they remove some plastics, some metals and paper and cardboard from the black bin waste, and that can be recycled, and then the remainder is incinerated and generates initially mainly electricity, which is exported to the grid. That's enough to power about 22,000 homes. There's a carbon saving because the waste is not sent to landfill, and essentially the methane saved is better for our environment than the emissions that are released from the incineration. And because of the emissions limits set by the Industrial Emissions Directive, actually all of the waste gases are scrubbed to quite a high standard anyway. So the Leeds RURF has been operating for a good few years now, but was always designed with heat capture in mind. So over the last 4 or 5 years, we've been working with Leeds City Council to develop the Leeds District Heating Network. This is one of the council's flagship investments, and really at the heart of their kind of decarbonisation plans for the city. Their key drivers for the scheme are around reducing carbon, reducing energy costs, and particularly for those people living in fuel poverty that live in Leeds social housing accommodation, and also to provide local economic benefits. So as part of the construction procurement process, they've put in clauses for local apprenticeships and training schemes to make sure that local people benefit from this big investment. So just to give you a bit of an overview of the whole scheme, this is highlighted in yellow is the extent of the network which is now in the ground and operational. So you'll see in the bottom right hand corner the RURF is located on the kind of east side of Leeds. There's an energy centre next to the RURF which contains 20 megawatt heat exchangers. So that's taking waste, sort of leftover steam from the steam turbines, and that converts that steam into low temperature hot water, which is distributed in pipes in the ground, very similar to the scheme in Sheffield. That is distributed to a second energy centre at Saxton Gardens, where there's also some backup gas boilers. And from Saxton Gardens, the network then goes right into the city centre, right along the hedgerow. It will supply the major civic buildings in the city centre, including the Civic Hall and the Town Hall. And the primary area where there's already buildings connected are sort of in the top right, where we've got about 1,800 social housing flats connected. So those are properties that are run by the council, and as you will imagine, many of the tenants in those properties can't really afford to run their heating. So it gives us some quite interesting challenges in terms of energy use. There's plans to extend the network in various different locations, and there's a lot of buildings that have already signed up to take heat from the network, and more to come over the coming years. So how has data kind of informed the construction of the heat network? Well, for this project, we kind of followed a fairly traditional kind of procurement route. So the first stage was probably consultant-led design, so feasibility, business case, concept design and procurement. In this case, it was all managed by Arup for the council. And feeding into that was a kind of a heavy reliance on published standards and some project-specific data. So we did have some data about the energy use from the council buildings. Post-procurement, there was a design and build contract with in fact, several design and build contracts, all won by Vital Energy, and they went through a process of design development and then construction, and now they're also operating and maintaining the network. Now it's live. So as they have constructed the scheme, an awful lot of operating data has been collected and continues to be collected, and that is helping them to operate the network efficiently. It's helping to fault find, and it's helping to inform their own future designs. But it's not all a tale of peace and happiness. The process of agreeing the design with the contractor was somewhat fraught, primarily because there haven't been that many new heat networks constructed in the UK. There's starting to be more coming online, and I think the industry is growing, and certainly standards and design guidance is being published, but it's still very much a sector that I would say is in its infancy, and we're all learning all the time. So just to give you a flavour of some of the data, so just thinking about those 1,800 flats which are already connected, the estimate of the peak heat load from those flats was about 10 megawatts, and actually through this winter the peak load we've seen, apart from odd few spikes, which we think might be errors in the data, essentially we've never really been above 5 megawatts. So we know that there's a lot of spare capacity that's been built into the design, and essentially that means the design is quite inefficient. In practice, it means that we can free up some of that capacity for new connections, and indeed we have got agreements in place to connect one of the hospital wings at St James's University Hospital, Jimmy's, and also a new school which is being built in that part of town. So it's kind of a mixed picture in terms of the data. So where do heat networks fit into the bigger challenge of how we decarbonise our heat? So currently, most of our heating in the UK comes from natural gas. Most people, I think, on this call are likely to have a gas boiler at home. Probably where you work also has a gas boiler of some sort. But one of the big challenges for our infrastructure over the next 10 and 20 years is actually, well, how do we get away from burning natural gas? And one of the things that people often say is, oh, well, we'll electrify, we'll put all of our heating onto electric. Well, actually, that's a big challenge because the gas network carries 3 times more energy than the electricity network. So even with heat pumps, which have for every unit of energy you put in, you might get 3 units of heat out, we still can't just rely on the electricity networks. It's going to be a very expensive way to go if we only do that. So heat networks are part of that solution. Electricity is part of the solution, and probably some combination of hydrogen gas being used for combustion as well for heating. But essentially it means that we have to redesign an awful lot of our existing energy infrastructure. And the more information that we can feed into those designs, the more efficient our designs can be, and therefore the cheaper it is going to be to achieve our decarbonisation goals. So just to sort of talk you through some of the kind of complexities of heat data and why it's important that we gather lots of different data from different sectors. On the left there, this is some analysis that was done by Octopus Energy. They looked at their customers who have smart meters installed, and they looked at a typical load profile for their customers. And they actually, in the lockdown, at the start of lockdown last year, they looked at which customers they thought were working from home and how their energy use had changed, how their gas use had changed in the week immediately after the lockdown. So it's important to recognise that not only are not all homes as efficient or inefficient as each other, but actually not all users behave the same. So actually, you know, we can't just rely on averages. We have to look at the real diversity of people and how they use their buildings. And on the right, there's a chart from one of the tower blocks that is connected to the Leeds District Heating Network. So that is a week's worth of data, and there's about 60 flats connected into that network. You can sort of spot a bit of a pattern that there are some periods overnight where the heat load drops, but there isn't this same pattern of morning peak, evening peak that a typical kind of professional household would typically expect. And actually, when speaking to the designer from Vital in preparing this presentation, he said, yeah, it's totally different from social housing, and indeed social housing in Leeds is totally different from social housing in London. So we need to be really careful that our designs reflect the different socio-economic situations, the different locations that we're designing for, and actually, as we start to build up this massive information about different types of buildings and different types of users, we can use those different profiles to inform our future designs, and hopefully avoid the situation where we're kind of doubling the size of our infrastructure just because we want to err on the side of caution with our designs. So in an ideal world, what would we do? Well, okay, just taking this feedback loop from all of this data that we're gathering from the O&M systems, if that operating data was published and was made openly available, it would help us inform those published standards. So we would have a better informed dialogue about what we do about diversity and how we design for lots of different users connected onto one network all at the same time. They're probably not all using heat at the same time. There's all sorts of points at which data would help inform the design. So there's real value in collecting this data and sharing it for the benefit of not just the Leeds network, but future heat network, and indeed decarbonisation of heat schemes in the future. But along with everything with heat networks, as a fledgling industry, there aren't really any open data standards at present, and it's all very well to say we can collect data from all of these 1,800 flats and we could publish it, but actually, unless you know what sort of building it's come from, when it was built, how efficient the building is, what it's used for, what kind of location it's in, who's living in that property or who's working in that property. So that kind of richness of data that needs to go alongside the raw numbers is really important too. And indeed, we've started working with BEIS and I think with Ofgem to talk about what data standards we need for all sorts of energy vectors, not just heat, but also looking at electricity and working with the distribution network operators on the electricity side to help them share more of their information about their networks too. And that is all from me. Thank you very much for listening. I shall be in the lounge later if anybody would like to find out any more. Thank you.
Awesome. Thanks, Martha.